the Angstrom Microscope versus the IMG-2263 Super Microscope by Dr. Ronald Stewart, THD, PhD. Copyright 2013 to 2017. All rights reserved. Here is a scientist at the IMG-2263 Super Microscope. There are about 11 to 12 super microscopes spread throughout the world, and this one allegedly may be in China. This particular microscope was invented sometimes around between 2015 and 2016. Here is going to be a comparison as to what it can do and versus what the Angstrom AM microscope that I invented can do as well, which can work on both inorganic and also organic matter, such as cells, molecular, organic, even at the atomic and subatomic levels. We learn more now as follows. The IMG-2263 Super Microscope is a combination of both an optical microscope and an electron microscope put together. Here is a brief video showing and explaining how it works. We use this under the Copyright Fair Use Act under research and also teaching. Thank you.
Put the sample into the TEM first. A valve will then be opened. Electrons will be projected on the screen from the electron gun. Electrons cannot be seen by the naked eye, but the image is produced on the fluorescent screen. The basic structure of an electron microscope and an optical microscope is quite similar. We use the magnetic field to focus the electrons to form an image. There is a camera under the screen. If the screen is lifted up, the camera catches the image on the screen.
We're going to examine the IMG-2263 Super Microscope a little further. Here in the bottom left corner we can see it says 5 nm. That's the most powerful magnification it can reach as far as a super microscope. Now, there where the arrows going up and down, those lines are supposed to be lines that connect electrons together. The most powerful magnification that it can reach down to may be maybe 2.0 nm at the very greatest. Now here, when it did this, what we do is we illustrate this with this following symbols. Here's the image it projected on the screen. The electrons shown by the yellow arrows, and the red arrow is a line of connection between the electrons. But the image is blurry, and this is the best they can show. However, when compared to the Angstrom microscope, the Angstrom microscope has been used in numerous peer-reviewed journals, and here in one, in Plural Dod, which is the Journal of Multiple Sciences, here it shows it was established in 2013. This journal is read in 140 countries around the world and has on 5 continents around the earth. It is also part and looked after by the Ministry of Technology and Science in Brazil, and approved by the government and also their scholarly filing systems or indexing systems as well. Here in 2014, the article was written about the video that we're going to get ready to see. Now, the name of this paper that was published, that I published there in 2014, was entitled Mycoplasma genitalium from 1.0 UM or microns to 1.0 NM nanometers. In other words, we're going to take this paper, as we can see here, Mycoplasma genitalium molecular imaging study from 10.0 times 10 to the negative power, and here is the abstract that was written on that. Now, this can be found at Plural Dodd, the peer-reviewed journal, in which I had aforementioned. As far as this paper is concerned, it gives a concise and detailed scientific evaluation of what the Angstrom microscope could do when it looked at the genitalium mycoplasma cell. Now, a normal cell is probably between 40 and 50 UM in diameter, where the mycoplasma genitalium cell is approximately as small as 1.0 UM or microns, which means that it is about 40 to 50 times smaller than an average sized cell between 30 and 40 UM. What we're going to take a look at next is a video, a supplemental materials peer-reviewed video that was used also to help explain beyond the space and page limitations of the paper, that explains more about the capability of the Angstrom microscope, entitled Theoretical Observations of Intracellular Mycoplasma Genitalium 1.0 UM to 1.0 NM or smaller by Ronald Stewart. The objective here is to go from 1.0 UM down below to 1.0 NM all the way down to an atom and seeing the electrons arcing off an atom. Then what we will do is show the results of that Angstrom microscope versus the results of the IMG-2263 Super Microscope and see how much more the Angstrom microscope can do, and then even beyond that as well. Here is that video as previously recorded and made. Theoretical observations of intracellular mycoplasma genitalium 1.0 UM microns to 1.0 NM or smaller by Ronald Stewart. At the bottom of this next image we have 1.0 UM, where the orange arrow points to. However, we are literally going to be going down into the cell where the yellow arrow points to in the upper left top corner. And here we can see we are getting closer and closer to the cell. And this is the cell that we will eventually be going down to 0.25 of 1 NM, where the white bar shows the diameter of the cell where the yellow arrow points to. Here in A, as we zoom into the original image in the entire image itself, where the yellow arrow points to, we can see better enhancement and resolution images expressed in B, C, and D. Here we are zooming down from 500 NM all the way down to approximately 35 UM. And in looking at this, we're looking probably at extracellular genitalium, which is also the inner workings of the cell. However, morphologically, deeper detail is also pertaining to intracellular and extracellular myoplasmas and highly fluoric ultrastructures indicated by dense contact of degraded bacterial membranes. And as we continue to go deeper within the cell, We now see, zooming in to the depth of the cell at 65 nm, 35 nm, and 15 nm expeditiously as we get closer and closer to our eventual goal. Now, the reason we're going very slow is to be able to try to observe every detail possible and what we might see in both what is in known biological sciences and also in the unknown, and trying to connect the proverbial dots together between the two. We are now zooming down in this part of the cell and approximately have a diameter of this part of the cell, which would be a conglomeration of most likely clusters of atoms or molecules. As we get closer and closer to this area, we will see this becoming more and more true. As we now see a 25 nm approximate diameter, in which we see more and more detail as we go deeper and deeper within the mycoplasma genitalium cell. What we see here in this white area is a conglomeration of numerous molecules together, which make itself more and more evident as we go deeper within the cell itself. And here, where it shows 2 nm, is approximately a molecule of. In some of these past images, what we have been viewing is clusters of atoms that influence the characteristics of the molecule and how they involve each other. But in this next image, we see in the upper top left corner a possible molecules of atoms in groups or bunches, and especially the one measuring 2.0 nm. However, the aqua-colored arrows are possible atoms where the aqua-colored arrows point to, as I reiterate, and where the orange arrow points to an atom that will be examined up close. However, we see the aqua-colored arrows pointing to other molecules or clusters of atoms. In about the middle of the image, we see another molecule or cluster of atoms. And the bottom left corner, we also see another molecule. The orange arrow points to the atom that we are zooming into that will measure approximately 0.25 of 1.0 nm nanometers. But we want to take this opportunity to take a look here at a molecule that has never been seen like this before in the history of biology at this small a microscopic measurement scale level. Within the red oval outline, we see this molecule in great detail. We're going to zoom into that a little bit later, but right there in the second circular red outline is the atom that we're going to be going to see the electrons arcing off of it before the end of this video. But now we're going to zoom in to this molecule as we zoom in to the left and take a much closer look at it, as we see here. Then we're going to zoom back out again. After we zoom back out, we will next be considering the 0.25 of 1.0 nm atom next, as follows. And what we want to realize is these atoms and molecules certainly are the functional group of atoms that are the chemical building blocks of life, and in this case help us to understand in a deeper perspective exactly what this particular cell may or may not be doing in both the known biological sciences and what we learn in zooming down to the cell in like manner. In the next image, we will go into even more detail. Here, what we see in this next image where the orange arrow points to is the atom that we have been taking a look at deep within this mycoplasma genitalium cell. The aqua-colored arrow points to, of course, the molecule or group of atoms. Now the long yellow arrow that points away from the atom that the orange arrow points to is a projected enlargement of the atom where the orange arrow points to. And as we get closer and closer, we can see more detail in that enlarged projection. However, the small yellow arrow that points to the right of the image points to yet a closer, more enhanced resolution of the atom where the orange arrow pointed to. And where the E is possible electrons that are arcing from a positive electrical charged environment. The electrons are also likely quantum blue, and due to quantum oscillation, they are arcing. It also appears to have positively charged electrical atomic arcing and is occurring and is popping in and out of the vacuum around the atom. There also may be some electrons that are reattracted to the proton. And here we move even closer so we can see the possible electrons as they positively are charged and arc away and in and around the top of the atom. Now we are much, much closer than 0.25 of 1.0 nm. Matter of fact, we may even be looking at this being smaller than 1.0 angstroms. But we're going to take it a step further and learn even more about this atom and the electrons we see arcing here. Could there be hundreds, if not thousands, of atoms or electrons getting ready to arc off this atom into its vacuum? As a new step that's never been seen before in a photo or in film. As we zoom back out away from this, we can see that there are hundreds, if not thousands, of electrons rising into the air or the vacuum around it, getting ready to arc. And this can happen in inorganic matter, and especially inorganic matter as well. How do the results then from the IMG-2263 and the Angstrom Microscope stack up against one another? We're here, again, we go back and revisit the IMG results. Here we can see that these symbols show that the electrons are where the yellow arrows point to, and yet they're very blurry and cannot see any activity as indicated in the red arrows. And next, when we take a look at it even closer, we can see that the red arrows indicate the activity and the yellow arrows indicate the electrons. Yet they're so blurry, and yet no detail can be seen. But in the Angstrom microscope to the right, we see the results of the electrons arcing off an atom, which you can see the atom in its surface in the background as well. And many, many more electrons in the background are getting to also arc, as we see these other ones doing here. But we take it even a step further. No one has ever seen this before. You are the first. But next, what we do is show that in the upper top left corner we see the results of the IMG-2263, where A is flashing off and on right now near the upper left top corner of this entire combination image. But yet the results are pitiful compared to what the Angstrom microscope can accomplish. For not only does it outdo the IMG-6623 far more results, but as we see in B right there, where the two V-shaped lines or A-shaped A-framed lines come and project, that right there is one of the electrons that is arced off of the lower atom. However, it is projected there in B and is in a lot larger where we see it right here in C right now. Right there where C is flashing off and on. This is in a high definition color image, as we see here, high resolution, very high resolution. However, we take it even further. Yes, we take it even further. Here in D, we can see that the pointers point to what may be subatomic particles that are breaking off the electron as it arcs off the atom below it in this vacuum. Yet we can see that the results of the Angstrom microscope are far, far superior and far, far ahead of its time, even more than the IMG-2263 that was manufactured in one of the world's leading microscopes. But yet we're going to take it even further as we come to the conclusion of this video. We're going to zoom in on C below the electron as follows. In conclusion, as we have now zoomed out to these small subatomic particles and we are zooming back away from them, we can understand that the Angstrom microscope is far, far superior for many years to come to any super microscope that exists now or into the foreseeable future. And it has many, many other capabilities of diagnosing and examining in a scientific data with its capabilities in organic manner and organic manner as well, in many different kinds of ways and circumstances, as we will give future study to. Thank you for watching.